In the extreme ice-bound regions of the Earth, something unprecedented is happening. Everywhere, glaciers and ice sheets have begun breaking apart and accelerating towards the oceans faster than ever imagined possible. Over the history of the Earth, ice has frequently advanced and receded, but now it's changing in ways we don't fully understand. With the future of the ice in question, photographer James Baylog risks everything to capture what's happening on film.
This is one of the scariest, dumbest things I've done in my life.
His incredible imagery is witness to one of the Earth's most powerful geological forces. A force that for the first time in modern human history is radically changing the planet. Extreme ice revealed, right now on this Nova National Geographic special. What began as a photographic assignment has become a mind-blowing odyssey into an unpredictable world, where entire landscapes teeter between solid and liquid states. On the Greenland ice sheet, a crack opens and a mile-wide lake pours down a 3,000-foot chasm.
But this water is just drilling down into the ice sheet.
One of the world's biggest glaciers shears off an iceberg that is nearly 1,000 feet thick.
You're not supposed to be able to witness things like this. Human beings don't generally get to see these massive features of the landscape changing and vanishing in front of your eyes.
The fact that the ice is changing is nothing new. Over the millennia, the expansion and contraction of ice across the continents has fundamentally altered the planet, gouging out lakes and valleys and pushing man around the Earth. In the past, the cycle of ice ages and periods of warming were caused mainly by shifts in the Earth's orbit around the sun. But now, humans seem to be driving these changes. Since the Industrial Revolution, our burning of fossil fuels has ratcheted up the output of greenhouse gases, like carbon dioxide, which trap heat in the atmosphere. Temperatures are climbing, and the ice is melting faster than ever. And nowhere is it happening faster than in the glaciers along the west coast of Alaska. Glaciers are like massive ice factories. High in the mountains, snowfall builds up and is compacted over hundreds of years. Gravity pulls it down in colossal rivers of ice. Some glaciers flow all the way to the ocean, shearing off icebergs in a process called calving. Over the last 40 years, temperatures here in Alaska have risen about 4 degrees Fahrenheit, twice as fast as the global average. Now, these rivers of ice are flowing faster and crashing even more spectacularly into the sea. Some people are taking advantage of the glacial fireworks while they last. Surfers towed in by jet skis are playing a dangerous game of chicken with the ice. It is rapidly calving glaciers like these that are the main contributors to rising sea levels. Alaska's Columbia is one of the biggest ocean-feeding glaciers in North America. In the early 1980s, the Columbia started flowing faster and began calving far more ice into the ocean than was being replenished by snowfall upstream. Baylog and the Extreme Ice Survey glaciologists are trying to figure out how much ice the Columbia is losing and whether or not it can survive. Just down the fjord, Baylog and Extreme Ice Survey engineer Adam LeWinter climbed down to one of the time-lapse cameras they installed a year ago.
Right, we have pictures.
The time-lapse brings to life the dynamic nature of the glacier, the ebb and flow of the ice as it calves.
It's a revelation. Every time we open up these boxes and download these images and bring them up on the computer and play them back, your eyes are popping out of your head.
Although calving is normal, the Columbia is hemorrhaging ice so quickly that in the last 30 years, the glacier has receded 10 miles up the fjord. Baylog's time-lapse images capture a rate of retreat that shows no sign of stopping. In the last year alone, the Columbia lost another half-mile of ice.
I really never expected that we were going to see changes of anything like this kind of magnitude in the period of time we had to work.
As rising temperatures create more surface melt, the water pours into the cracks in the glacier and wedges it apart. The result is increased calving and a quicker demise of the glacier. Meanwhile, after several days of laser tracking, Tad Pfeffer knows how fast the Columbia is moving. 50 feet per day, 8 times faster than it was 30 years ago.
Go back to 1980. Here on this bedrock, we had ice above us 1,500 feet. Look at the trim line over there. That's where the ice surface was in 1980. And all of that volume is lost because this calving is so fast and snowfall upstream isn't resupplying it. So in that sense, yeah, it's going too fast and the glacier is kind of collapsing.
Pfeffer suspects that the Columbia is long past its tipping point, and it's only a matter of time before it withers away entirely. The problem is, it's not just the Columbia that's on its way out. Glaciers everywhere, across the Rockies, Andes, Alps, and Himalayas, are in their death throes.
The people that live near the mountains and watch the glaciers know that the world is changing. We are heading towards Glacier National Park without any glaciers. We're seeing, huge changes in Glacier Bay in Alaska and other places. If you go, if you look, you see it.
The consensus is that in the next 50 to 100 years, mountain glaciers almost everywhere will simply disappear. From the loss of mountain glaciers alone, sea levels will rise by almost a foot, displacing millions of people around the world. But the biggest cost will be the loss of these huge natural reservoirs of fresh water, water that 1/6 of the world's population depends on. The hardest hit will be in Asia, where nearly 1 billion people get their drinking water from Himalayan glaciers. The abrupt collapse of the world's mountain glaciers raises even more disturbing questions about the Earth's biggest tracts of ice: the polar ice sheets of Antarctica and Greenland. The potential for the polar ice sheets to flood the planet is staggering. If all of Greenland and Antarctica were to melt, the oceans would rise 200 feet. But over geologic time, these ancient bulwarks of ice have withstood many bouts with climate warming. Until a few years ago, scientists thought the ice sheets were simply too big and too dense to be an immediate risk. But the latest evidence is making them rethink. The first wake-up call came from the West Antarctic Peninsula. In the summer of 2002, a NASA satellite photographed a Rhode Island-sized slab of ice called Larsen B as it sheared off the ice shelf. Other collapses followed, turning the assumption that it would take thousands of years for the big ice sheets to melt on its head.
The ice sheets surprised us. We sort of thought that the little glaciers would melt when it got warmer and that the big ice sheets wouldn't do much. And all of a sudden, the big ice sheets started rumbling faster and the Larsen B was falling apart. And we said, whoa, that wasn't supposed to happen.